Here we are at number 4. Number 4 is just like number 3 with a couple added layers of awfulness onto it. But basically you're trying to cause a precipitate that's there. Okay, fine. So if we're trying to cause a precipitate and it's a Ksp problem, we can set these up every single time the exact same way. So the nickel plus 2 aqueous in this case with the carbonate. And I know that Ksp is going to be the nickel times the carbonate that's there. All right, I got an I got a C, and I got an E, and I don't care about this. And what does it tell me? It tells me that I have a 3.5 times 10 to the negative 4th molar solution of this. So 3.5 times 10 to the negative 4th molar that's there. Now, they've given me 100 milliliters, and they've given me all sorts of other things. Let's just keep our eye on the ball. What is this going to be in order to start causing a precipitate? Well, we know we can just put in X there, because if it goes beyond X, then it'll go back over to the left and it'll start causing a precipitate. So let's just start with that. They told me that the Ksp is 1.4 times 10 to the negative 7th. And then that's going to be equal to X times 3.5 times 10 to the negative 4th. Like so I get out my calculator. 1.4 times 10 to the negative 7th divided by 3.5 times 10 to the negative 4th gets me 4 times 10 to the negative 4th. So my concentration of nickel, which is my X, is 4 times 10 to the negative 4th molarity. That's what I need. Now that is in moles per liter. So if that is in moles per liter, all they want to know now is they want to know how many grams it's going to cause. Well, we're going to be doing it in a 0.1 liter solution, 100 milliliters, which is 0.1 liters. So we're going to multiply this by 0.1 liters in order to kill the liters. Now I'm in moles, so all I have to do is multiply this by the number of grams per mole, and we are done. Because what do I have? Well, I've got this goofy, ugly looking thing here that is nickel nitrate, NiNO3 2, with 7 waters. So remember, this is a hydrate from way back in our ionic unit that we did. Don't freak out. It's just a big compound that's pretty complex looking, but it's really no different than anything else. And the nice thing is there's only one nickel in there, so I only have to worry about the fact that there is one nickel that is there. So I get out my calculator and I add up the mass of this. Nickel is 58.7, and then a couple of 48s for those 2 groups of 3 oxygens that's there, and then a couple of 14s for the 2 nitrogens that are there. So that part weighs 182.7. And then I've got 7 waters that are included in that. So that's 7 times 18, so that's 126 plus the 182.7. This whole shooting match here together weighs 308.7 grams per mole. So I come back up here and I have 308.7 grams per mole. So I just include that and I'm done. So the 308.7 at the 0.1 at the 4 times 10 to the negative 4th gets me a value of about 0.012 grams. So 0.012 grams, like so. That guy there is